In this tutorial, we will illustrate how to radiometrically calibrate an ocean optics spectrometer in SpectraSuite for applications that will utilize a bare fiber. This tutorial assumes that you have already installed the drivers for your spectrometer and have SpectraSuite installed on your computer. If not, please log on to oceanoptics.com and download the tutorial for getting SpectraSuite up and running on your PC. For performing this radiometric calibration, we will use a USB 2000 Plus spectrometer, LS1 Cal calibrated light source, a 600 micron Vis-NIR fiber optic patch cable, bare fiber adapter, and the SpectraSuite software. First, you should connect the power to the light source and turn it on so that it can begin to warm up. For the LS1 Cal-INT, it is recommended to let the lamp warm up for at least 20 minutes. Next, connect one end of the patch cable to the bare fiber adapter. Connect the other end of the patch cable to the SMA connector of the spectrometer. Make sure that the USB cable is connected to the spectrometer and the USB port on your PC. This completes the setup. Now that the setup is connected, start up the SpectraSuite software. You should be greeted with the SpectraSuite interface showing a picture of your spectrometer in the Data Sources pane. To begin the radiometric calibration, click on File, New, and New Absolute Irradiance Measurement in the menu. You will see the Absolute Irradiance Setup dialog box appear. Select New Spectral Acquisition and click Next. Make sure that your spectrometer is highlighted, indicating that this is the source of spectral data, and click Next. In this tutorial, we will take you through the steps of performing a new calibration. Therefore, select New Calibration in this window and click Next. Before we set the acquisition parameters, we need to place the bare fiber adapter into the LS1 Cal. Loosen the set screw and insert the bare fiber adapter into the port on the light source. Make sure that the bare fiber adapter slides all the way into the port on the light source, and then tighten the set screw. Once the bare fiber adapter is properly seated in the LS1 Cal, we can set the acquisition parameters. Clicking the Set Automatically button lets the software select the best integration time for your experiment. You may have to click this button more than once to get to the last peak value and recommended peak value text boxes to both turn black, indicating that the software has chosen an appropriate value of the integration time. Add any averaging and boxcar smoothing in this window and click Next. Making sure that the bare fiber adapter is properly inserted in the light source, click the yellow light bulb button to store the reference spectrum and click Next. Blocking the path of the light source, click the gray light bulb button to store the dark spectrum and click Next. In the next screen, you will be asked to load the lamp file from the CD included with your light source. Insert the CD and click the Browse button. Navigate to the location of the CD and select the file that begins with the name LSC and has a _fib.lmp extension and click Open. Then click Next. In this screen, we need to input our fiber diameter or collection area. Since we are using a bare fiber, we input core diameter of our fiber. In this tutorial, 600 micron in the fiber diameter text box under collection area. The spectrometer calibration preview frame should show two lines of different colors nearly on top of one another. This indicates that the calibration file and the measurement of the lamp that generated the calibration file are in agreement. SpectraSuite generates a calibration file for your spectrometer at the end of the Absolute Irradiance wizard. To save this file for future use, click Save to File. Give the file a name and save it to the location of your choice. Clicking Finish brings you back to the main SpectraSuite window.
In the main SpectraSuite window, you will see a graph of the calibration light source with absolute irradiance in microwatts per centimeter squared per nanometer on the y-axis. You'll also see wavelength in nanometers on the x-axis. You may have to click Scale Graph to Fill window in order to see the entire spectrum.
A good check to see if you have performed the calibration correctly is to cross-reference the values listed in the lamp file with the values being measured in SpectraSuite. For instance, our lamp file shows a value of 0.251 microwatt per nanometer at 600 nanometer. Clicking on the spectrum graph at 600 nanometer to activate the cursor, we see that the value at 600 nanometer is approximately 0.25 microwatt per nanometer. Therefore, it appears we have done the calibration correctly. Once your system has been calibrated, you do not need to recalibrate the system each time you wish to take a measurement, provided you have not removed the fiber from the spectrometer. You have calibrated the fiber and spectrometer as a system, so any alterations to that system will mandate a recalibration. These simple steps should assist you in getting your spectrometer radiometrically calibrated for applications using a bare fiber. In the next part of this video series, we will build on this tutorial and measure the total power output of an LED. For this and more instructional videos, log on to oceanoptics.com. You can also reach us via email at info@oceanoptics.com.